Hello viewers, welcome back. In this video we will discuss about bit access operation in a byte or in a word. As you know that there are 8 bit in a byte and 16 bit in a word. In this video we will discuss how we can use that bit in PLC user program and how we can use in HMI program. If the tag, byte tag or word tag from flag memory like MB 20, that means byte 20, then it is easy to use that M20.0 is the first bit of that byte and M20.7 is the last bit of that byte. And for the word MW suppose 22, so first bit of that word 22 is 0 and last bit is the M23. Why it is 23? Because in word there are 2 bytes starting with 22 and ending with 23. So 22 and 23. So last bit of that word is MW M23.7. So if we go in the HMI program, that here it is easy that M20.0 and here M20 suppose 23.7, it is easy to write, easy to use that bit M23.7. it is easy. But if the tag from local variable, that means it is from data block, then it is not easy as the flag memory. Okay, now here if I open the HMI DB, I have declared 2 tag. One is called the bit access underscore byte and second one is the bit access underscore word, and here data type is byte and word. And now we'll use, I will floating this data block here. Okay, now we'll use the bit of byte and word from the data block. We can do by 2A and it depends on the data block access. If we click the data block, if we select the data block and right click and go to properties, then we can see here in attributes the data block attribute is optimized block access. That means there are in earlier video I have already told that there are 2 types of block access of data block. One is called optimized block access, another is called standard block access. Now first I will use optimized block access. For optimized block access, to write the bit of that byte, we have to write the HMI DB like that. See here only 2 boolean tag is available because binary operation need the boolean tag. Here only here if we see that here start and stop, only 2 boolean tag available. So from the bit access byte, I will write the bit by write HMI DB, then dot, then we have to write full tag, means bit access underscore byte, then give a dot, then percentage, for binary operation give x, then give a bit number. if the first bit, if you want to use first bit, then give a 0. If you want to second bit, then give a 1. So for now I will use the first bit. Okay. For output coil, I will use the HMI DB bit access underscore word, then give dot, then percentage x 0. Okay. By this way you can use the bit of that word. If you want to use the last bit of that word, you have to write here x15, like x15. Okay. For now I will use the first bit. Okay. Then I will use the bit in the HMI. So for command from HMI, I will use the bit access byte and read the PLC word tag in HMI. I will use the bit access underscore word. So now go to HMI skin. I am minimizing this. Here I will take a object rectangle here, write the HMI Lesson-06, that the bit access. Also, how we can use the bit from the word or byte in a button, we can see by this video. First I will take a button from the element and give a bit command name, and that is from the optimize block access. So here I'll write as a bit command by optimize block access. Also I'll take a circle from the basic object here. So I'll give a command by the button by using event. Here press, when I give a press, it will go to command to PLC. In HMI Lesson 2 we have used the button, and in that button we have used the binary tag, and that time we have used the edit bit as a set bit and reset bit. But here our tag is not a binary tag, it is a word or byte tag. So we have to use the set bit in a tag, and the tag is HMI DB is the byte, and here you have to write the bit number. Here for now we are using the first bit, that is 0 bit. Here we already use that x0, and that is the first bit. Okay, now we are copying, and in release also we have to use the reset bit in a tag. Now same. Okay, now here I will dynamically change the color of that circle by choosing the HM animation, and here from the appearance select by 3 dot. Here I will use the bit access word for read the value from the PLC, because here we have used the bit access underscore word. We want to see the coil status, so we have to select the word tag here from the single bit. Okay, if the value of that bit access word bit number 0 is 1, that time it will show the green. Okay, now save and simulate the HMI. Okay, same way we have to download the program to PLC. Okay, now go online. Okay, from the HMI, if I give a command that bit access underscore byte value should 1, so giving command, yes, it is 1, as well as the circle is green. Okay, and this is how we can use the bit of byte or word if the DB block is optimized access. Now if the DB block is standard access block access, then how we can use the bit? I'm going offline. Now I'm going the properties of the data block. Now deselect the optimized block access. Now it is standard block access. If you go to HMI DB, here you can see that there is a extra column, is called the offset, and this offset you can see as a address of that variable. And how? If you compile, then you can see the address. So for bit access underscore byte, address is starting address is 12, and for word it is 14. So when the DB block is standard access, then how we can use the bit of that byte or word? Now I am taking contract and a coil. Okay, now that HMI DB and DB number is DB3, so you have to write that DB3 and here DBX, X for binary and B for byte. So if it is byte, so it is byte, or for W it is, so for now it is X, and starting address is 12. So I have to give a 12. Then if you use the first bit, then you have to give a 0. We have already used the first bit here, so here I will use the second bit. Okay, you can see that for the standard block access you can use the bit access of that byte by using that tag, same as the optimized access. Also you can use the bit access by this way. Okay, here we will use db3.dbx 14.1. One thing you have to remember, that if you use the standard access and use the address like this, then when you read the tag from the PLC to HMI, then your byte will swap. That means the 14 in 14 has a 14 is the address of word, bit access word, so it has a 2 byte 14 and 15. So when you read the tag bit access word in HMI, that time your tag will swap. So 14 goes to 15, 15 goes to 14. Now let's see. Okay, here I will take another. Okay, bit cmd command, here std standard. Okay, Here I will take a okay. Now I'll write the press command by using the set bit in a tag, and tag is same as byte, and here bit is 1. Why bit is 1? We have used 12.1, so it is bit number 1. Okay, and release, we should use the reset bit in a tag, and tag number same and bit number 1. Okay, and for animation of the circle in appearance, we have to select bit access underscore word and single bit. Here we have to use the 1. As for the optimize block access, we have to give a 1. Okay, okay, when the value of that bit is 1, that time it will give a green color. Okay, okay, download. Go online. Okay, if I give a command by this bit command standard here, see it is 1, it also 1, but here you can see that it is not green. Why? If you go HMI DB here and online, go online, see here it is 2, but when you give a command by this one, it's showing as a 1, but when you give a command, that time it's here shift, it is shift. So when you using the standard block access and for bit access by using the address, that time your byte will be swapped. You can make the circle green by here. I have told that byte is swapped. So byte swap means from 0 to 7 is the first byte, so 8 and 9. So here we have to use the bit 9. Okay, now if we simulate again the HMI, okay, see it is now green, so it is swapped. So for word it swap the byte, for double word it swap the word. Okay, if you go back to the, if you go back to that here branching and give a that here, if you write as a 1, so that here percentage x1 and 14.1 is not same, because by the use the tag, it is the second bit. You can use in here, if we use the another circle here, we can see that if you use percentage x1, then your word will not swap, your bit will write same. Okay, now again simulate the HMI. Same way, we have to download the program to PLC. Okay, here if you give a command, see both are 1. So when you write the tag by using %x1, that time your when you read in the HMI, your bit number will be same as the program. Here is the x1, here is the x1 means second bit, here you can use the 1 means second bit. When you use the dbx 14.1, that time your bit will be swap. That means byte will be swap, and you have to use the bit as well. Okay, thank you.